Hey, MAT-246, Ian here. Infinity, a concept that doesn't end, trailing off forever and ever. There's a wide range of definitions for infinity. We could look at the Wikipedia definition for it, an abstract concept describing something without any limit. Or we could think about it as the number of numbers between 0 and 1. There are so many fractional capabilities that the numbers just keep coming. They're endless, they're infinite. But that's small scale, chump change as I like to call it. Let's look at something a bit more interstellar. Here is Vega, the brightest star in our night sky. Approximately 5,878,604,619,700 miles from our tiny planet here. Think about that number for a minute. That number lies just in our own galaxy. Think about the hundreds of thousands of other galaxies that stretch far beyond our own. That 5 trillion mile distance is starting to look more like the distance between 0 and 1. Now if we take it a step further, the distance to the end of the universe, well, it's infinite. So infinity could be something as small as from 0 to 1, or it could be from here to the end of the universe, stretching beyond other stars and galaxies and even other life forms. How many possible ways can you define infinity? Well, the number is infinite. There's so many possibilities that it becomes impossible to define it. But how about measuring it? Okay, so we can't really measure infinity, but we can measure the area under a curve as it goes off to infinity. But we need a graph for that. Oh, there we go. So as you can see, this is the graph of 1 over x cubed, and it goes off to infinity in both directions. The only way to get the area under the curve would obviously be to take the integral. So let's do that. Our integral starts at -1, and it trails off to infinity. Now we can't just plug in infinity into our integral. So what we have to do is we have to substitute infinity for a variable. So in this case we'll choose n. Then we have to limit that variable going off to infinity. Cool. So now we treat the integral as any other. We push up the x cubed, it becomes x to the -3, and we take the integral of it. It becomes x to the -2 over -2, evaluated between 0 and n. And n is limited to infinity. Now we evaluate it as we would any normal integral. It becomes -1 over 2 times infinity minus -1 over 2 times 1. The term on the right just turns into 1 over 2, 1/2, and the term on the left, because 1 is being divided by infinity, it turns to 0. This happens because as you divide 1 by bigger and bigger numbers, the results get smaller and smaller, eventually leading up to 0. Therefore, the first term drops off, the second term stays as 1/2, and our result for our integral of x to the -3 is 1/2. There you have it, and that is how we measure infinity.